Assalamualaikum and salam sejahtera. I am Daniel Hisham as a representative for our group members Intan and Mahfuzah. In this video presentation, we would like to present linear programming topic. So I will start first. Linear programming is a mathematical modeling technique useful for the allocation of scarce and limited resources such as labor, material, machine, time, warehouse space, and many more, to several competing activities such as product, service, job, new equipment, and project on the basis of a given criteria of optimality. Definition of linear programming problems. A mathematical technique used to obtain an optimum solution in resource allocate problems such as production planning. It is a mathematical model or technique for efficient and effective objective. When solving a problem using linear programming, the program is put into a number of linear inequalities and then an attempt is made to maximize or minimize the input.
Hi, I am Intan. I would like to present about graphical solution in minimization problem. In this tutorial, we will graphically solve this minimization problem using the objective function line approach. Note that the use of the graphical approach is limited to 2-3 for reference purposes. For constraint 1, when x equals 0, y equals 2, and when y equals 0, x equals 6. For the second constraint, we have 0, 5, and 2, 0, which we also join to form the constraint line. For y less than 4, the line is simply at y equals 4. We have the point 0, 2, and 6, 0, which we join to form the constraint line. For the second constraint, we have 0, 5, and 2, 0, which we also join to form the constraint line. For y less than 4, the line is simply at y equals 4. Now, since the first two constraints are greater than constraint, they will be certified in the region above the line away from the origin, and y less than 4 is simply certified below the line. The directed region certifying all the constraints at the same time, called the feasible region, is this area shaded in blue. Now, the optimal solution to this problem will occur at an extreme or corner point of this feasible region. Let's label that and C for reference purposes. Now recall that the objective function is to minimize 5x plus 7y. So, the corner point that gives us the minimum value of the objective function is the optimal point. For example, we have 5 times 7, which equals 35. 35 seems to be appropriate for this problem. Next, we find point to draw the objective function line. When x equals 0, y equals 5, and when y equals 0, x equals 7. So, the objective function line is this blue dotted line here. Recall that it is a minimization problem. So, to use this line to determine the best extreme point, we slowly move it down toward to the origin parallel to itself. If this were a maximization problem, we would move the line upward away from the origin. The last extreme point the line touch before leaving the visible region if the optimal point. Let's use the substitution method. And that simplify to 30 minus 15, 15. And that simplify to 30 minus 15y plus 2y equal 10, which give negative 13y equal negative 20. And that give y equal 1.54. Substituting, that is s equal 1.38. So the coordinate at point B are x equal 1.38 and y equal 1.54. We have 5 times 1.38 plus 7 times 1.54, which give 17.7. So the optimal solution occurs at point B, and the corresponding minimum value of the objective function is 17.7.
Alright, so here we are going to learn how to solve this maximized linear programming problem using the solver feature of Excel, which you have to pre-install. So here we got 3 variable cells. These are just labeled for the cell. The actual cell holding the variable value will be the one underneath that. And now we are going to start by programming in our objective function. So we are trying to maximize objective. It will equal to thousand times A plus 400 times B and 118 times C. As for the constraint, we will do it separately. Left hand side is 20 times A plus 6 times B plus 3 times C, and it's smaller than or equal to 182. And our next inequality are as follow in the video. So once I have my variable box, objective function and constraint, I go to data tab and use solver. For the set objective, we click on the objective box and select maximum problem by changing variable cell. We select the underneath variable cell. Then we add subject to the constraint. and insert for the cell reference and constraint. Select a solving method, simplex linear programming. Then the problem will be solved.